Welcome to Unit 5, Section 7. Throughout the course of this unit, we've looked at graphing systems of equations. And remember, a system of equation is just two or more equations graphed on the same xy plane. Then in our previous video, we looked at graphing linear inequalities that had a shaded region as their solution set. In other words, there's multiple ordered pairs that made that inequality true. Well, today we're going to mash those two concepts together, and we are going to graph systems of linear inequalities. So this is just two or more linear inequalities graphed on the same xy plane, and their solutions will be the overlapping regions that are the solutions of their individual inequalities. All right, let's jump into a few examples here. In example 1, it says to tell whether each ordered pair is a solution of the system of linear inequalities. So here's our system. It's this brace that looks like a face, and then we have two inequalities. Y is greater than 3 times x, and y is less than or equal to x minus 2. And if the ordered pair is a solution to the system, then it makes both statements true. So let's substitute in the point -2, -1, and find out if it makes both of these statements true. -1 is greater than 3 times -2. That makes -1 greater than -6. Yes, that's a true statement. Now let's substitute -2, -1 into the second equation. So -1 is less than our -2 minus 2. That gives us -1 is less than or equal to -4. Well, this is a false statement. All right, -1 is not less than or equal to -4. It's actually greater than. And because it's a false statement, we have to say that -2, -1 is not a solution to that system. So remember, you got to plug them into both equations, both inequalities, and make them make true statements. Let's test the point 0, 4. All right, so 4 is greater than 3 times 0. Is 4 greater than 0? Yes, that part is true. Let's test 0, 4 now to that second equation. We have 4 is less than or equal to 0 minus 2. All right, so 0 minus 2 is -2. 4 is not less than -2. So because we have a false statement here, we have to say that nope, 0, 4 is not a solution. All right, well, let's get some examples of what these graphs will look like. Example 2 says to graph the system of inequalities below, give one solution. Give one solution of the system. All right, let's start off by graphing this first one here, which is y is greater than or equal to -1. So this is a horizontal line, and it's a solid line because it's greater than or equal to. So here is our solid line, and we want everything that's greater than or equal to that -1. So our shading needs to be above that line. So we'll shade in our region up above. Okay, that's close enough. Next, we're going to graph the line y is less than -x plus 2. So here I have a slope of -1 and a y-intercept of +2. So let's graph our y-intercept here and a slope of -1. So I'm going down to the right 1, down 1 to the right 1. Okay? All right, now this is all the y's less than that, so this should be a dotted line. So I'm just going to continue on here with these little dots. I should say it's a dashed line. So here's our dashed line coming through. And I want everything I want all the y's that are less than that line. So if I test the point 0, 0, if I put 0 in, I'll make the statement 0 is less than 2, which is true. All right, so that means we need to shade now. We're going to do some shading, but we're going to change some colors. So let's just quick change this to red. All right, we're going to shade below this new line here. All right, and we'll get right up close to that boundary line. There we go. All right, so the solution to this system occurs in these overlapping regions. So remember, we shaded above this horizontal line and we shaded below the dotted line. So the overlap is everything that we shaded here, and actually all the way up here as well. Okay, so this overlapping region contains all of my solutions. So let's just take the point, how about -4, 2, right there. This should make a true statement for both of our equations. If we want to test that point out, we can do that. We got 2 is greater than or equal to -1. Yep, that's true. Now let's plug in our next one here. 2 is less than the opposite of -4 plus 2. That would be 2 is less than 6, and yep, that's a true statement as well. So here in this overlapping region is the solution to our system of inequalities. All right, so that can be a little bit confusing. Let's do another example here. In example 3, we're going to do the same thing. Let's put these into slope-intercept form. So this first one, I'm going to move my 2x over to the right side. That gives me y is less than or equal to -2x plus 8. And I'm going to do the same thing on this next one. I get y is greater than -x plus 3. Oops, that's -x. All right, so let's start off by graphing one line here at a time. And we're going to start off by graphing the -2x plus 8. I got a y-intercept here of +8 and a slope of -2. So I'm going to come down 2 and to the right 1. And it looks like this is going to be a solid line because it's a less than or equal to. All right, there's our line. Make it nice and straight and solid. And I'm going to do my shading now. So let's shade. I want all the y's that are less than that. So let's test the points 0, 0. 0 would go in for y, and 0, that would make the statement 0 is less than or equal to +8, which is true. All right, so we're going to shade everything below this line. All right, next up, let's graph our other line. We got all the y's greater than -1x plus 3. So we got a y-intercept of +3. And this has a slope of -1. So down 1 to the right 1. And it looks like they're going to intersect right about here. All right. And this should be a dotted line here. So let's see if I can make these nice dotted lines. And there's that boundary line right there. Okay, so kind of some confusing lines there, but we want all the y's that are greater than that. So this shading now, we're going to change colors. And we'll change this up to be our gray here, is going to be shaded up above here. So you can kind of barely see that on your video, but we're shading above that line. So our overlap is this region right in here. Let's change that color up with one more time. Let's make it a little bit darker here. So the overlapping region is going to be this purple region right in between these two lines. And that is going to be our solution. So I could take the point 0, 5. 0, 5 should be a solution to both these equations. Let's test it out and see. If I put 0 in for x, that will give me 2 times 0 plus 5. That's less than or equal to 8. Yes, that's true. Our next point then would be 0 plus 5 is greater than 3. Whoops, greater than 3. And that's true as well. So you can see it's this purple shading here that's going to contain the overlap of the gray and that red. And that's going to be the solution to this system of inequalities. All right, in our final example, we're going to graph this system of inequalities below. And I'm going to give you a hint. These first two, x is greater than or equal to 0, y is greater than or equal to 0, is just going to limit you to this first quadrant. So just keep in mind that all of your shading is going to occur just in this first quadrant. See if you can follow our previous example from example 2, graph the x and y intercept of these two linear equations or change them into slope-intercept form and do your shading, and we'll talk about your solution to these inequalities tomorrow in class.